Loose coupling can be applied to all sorts of things, including software design. Software developers use loose coupling to make applications more reliable, scalable, and easier to update. To illustrate how they do this, we'll harken back to our hypothetical video processing application. To reiterate, the application has two basic functions: the web interface that the users interact with, and the logic to process the video according to the user's wishes, resizing it, rotating it, colorizing it, etc. The web interface and application logic are tightly coupled. They always run together. For example, if a user uploads a video for processing, that video processing occurs on the same instance the user happens to be connected to. This is called a monolithic architecture. The word monolith refers to a single block of stone. So a monolithic application is one in which all of the application's functions occur in the same place, in this case on a single EC2 instance. Monolithic applications are tightly coupled. But here's how a developer might re-architect the application using loose coupling. Run the web interface on one instance and the video processing on another instance. And what you end up with are essentially two services: a web service and a video processing service. They're separate services running on separate instances. Services broken up in this way are often called microservices. The micro in microservices does not refer to the processing power or memory or anything like that. A microservice performs a small number of functions compared to the rest of the application. In some cases, a microservice might perform only one function. Why would you want to take a monolithic application and break it down into microservices? Well, suppose that the developers need to update the video processing portion of the application. Because the services are loosely coupled, they can update the video processing service without impacting the availability of the web service. And there's another advantage to the loose coupling approach. Because you can scale the services independently, you can achieve better cost optimization. For example, you can give the instances running the video processing service a lot of memory and a lot of processing power, and you can run the web interface on less powerful instances to save some money. But remember that whenever you do loose coupling, you have to have a way to tie those loosely coupled components together. So how do the web service and the video service talk to each other? When a user uploads a video they want processed, they're interacting with the web service. How does the web service tell the video processing service, hey, here's a video you need to process, and here are the options the user has selected? That's where the simple queue service, or SQS, comes in. Essentially, SQS lets you pass messages between services. You start by creating a messaging queue. When the web server gets a request to process a video, it places a message in the queue with whatever information the video processing service needs to process the video. That message might include the path to the source video file, the options the user selected, and a unique request identifier. The video service periodically checks or polls the queue for new messages. It grabs the message from the queue, looks at the information in the message, and begins processing the video. Because SQS is elastic and highly available, the web service can send into the queue as many messages as it needs to, and each message will patiently sit in the queue until the video processing service picks it up and processes it.